So good morning to all of you students. Today I am going to explain the insertion and deletion in a heap. So insertion in a heap, it takes place at the end of the heap, and deletion takes place at the root. So today, or we can say this video, covers the insertion and deletion of the heap. Now I would like to say that this deletion is also important because this is another way of sorting a heap. So we can sort an unsorted array by using the deletion operation in the heap. So here we will focus on the max heap. Otherwise we can also use min heap. So for this insertion and deletion we will use the max heap. So first we will see what is the insertion, and after that we will see what is the deletion. This insertion operation in a heap, this is also known as the creating a heap or building a max heap. So let us see what is this insertion. So elements can be inserted in a heap at last position of the heap. We use some steps. Use following steps. Use following steps to insert the element in the heap. Step 1. Increase the size of the heap by 1. Increase the size of the heap by 1 so that it can store a new element. Insert the new element at last position of heap. So we will insert it at the last position. Now, as soon as we insert the element in the heap, it will distort the order property of the heap. So this insertion, may distort the order of heap. That is to say, if value of the parent is, the value, as we know in max heap, the value of the parent should be greater than its child, but if the value of the parent is less than its child, then heapify the new element, heapify the new element to restore the property of the Maxheap. Else go to step 1 until no more elements are left to insert. So we have to check here whether the parent is greater than the children or not. Now we will understand this with the help of the example, that how we can create a heap or how we can build a Maxheap. Now we will see an example. Let us consider a list which is containing the elements 16, 21, 8, 10 and 31. So this list is containing 5 elements. We will insert in the heap one by one. So first we will insert 16. So first insert 16, because this is the only element, so it will be inserted. So it can be inserted and the index of this will be 1. Now we will insert 21. Insert 21. So this is 21 can be inserted at the second position. This is first, this is second. Now we have to see here, as soon as we insert this 21 at last position, so what happens? Now the value of the parent node is less than its child. So it is distorting the property of the Maxheap. So what we will do? Swap 16 and 21, or we can say we will heapify it. So swap takes place here and now it becomes 21 and 16 like this. So now it is Maxheap. This is Maxheap. Now we'll insert 8. Insert 8. So this 8 can be inserted because this is first, second, third position. It should come at third position. This is 21, 16 and then 8. First, second, third. Now we'll check the newly inserted element is 8 and this 8 is less than 21, so we don't need to change because this is still a Maxheap, so there is no change because it is a Maxheap. Now we'll insert 10. 16, 21, 8 has been inserted. Now insert 10. Insert 10. So this 10 will come at fourth position. This is first, second, third and fourth. 21, 16, 8 and 10. One, 2, 3 and 4. So this 10 will come at fourth position. Now we'll check this new element, this is 10, so this is less than 16, therefore no change, because it is not violating the condition of the heap. It is still a max heap. Now we'll insert 31. 31 will be inserted at 5th position. 21, 16, 8, 10 and 31. This is first, second, third, fourth and fifth. Now we'll check, because this 31 is greater than its parent. So what we will do? We will interchange this to restore its heap property. Now what we will do? We will swap 16 and 31 to restore its property. We will swap. Now it comes out to be 21, 31, 8, 10 and 16. Like this. Now again we will check at this position, this 31, this is greater than 21. So now again, because this is distorting the property of heap, so what we will do? We will make one more swap 21 and 31. 21 and 31 to restore the property of heap. So comes out to be 31 will come at the top, then 21, then 8, 10 and then 16. Like this. So this is first element, second, third, fourth and fifth. So now this is the Maxheap. So this is the Maxheap. Rather is a finally, because we have created all the 5 elements in this. So we will recall it, like how we have created this heap. First we have taken a list. It is containing 5 elements. Then we have inserted one by one using this procedure. First what we will do, we will increase the size of the heap by 1 so that it can store a new element. As soon as a new element is inserted, we will insert the new element at the last position. As soon as we insert this new element, it will distort the order property of the heap. So we need to restore it. So if the value of the parent is less than its child, then heapify the new element, else go to step 1 until no more elements are left to insert. So this is the procedure. In this way we have created a heap. Now we will see the deletion in the heap. So now we will understand the deletion operation in the heap. So one important thing is there in this deletion operation in the heap. Deletion can be performed at the root of the heap. So deletion operation can be performed at root. So in heap, this deletion can be performed at the root. And if the heap is Maxheap, then largest element is deleted, and if min heap then smallest element is deleted. So if the heap is max heap, then we will delete the largest element, and if the heap is min heap, then we will delete the smallest element. So this is the largest and this is the smallest, and we will perform the deletion operation at root of the heap. So we will use some steps. Use steps below. Step 1, delete the root element, and then replace the deleted element by last element. So replace the deleted element by the last element. So first delete the root, then replace the deleted element by the last element, and this replacement may destroy the order property of the heap. So this replacement may distort the order of heap. So if, that is to say, if value of parent node is less than equals to its children, then in this case what we will do, we will heapify the root downward to restore the property of the heap. Else go to step 1, until no more elements are left. So these are the steps that we follow to delete element in the heap. Now we will see this with the help of example. Now we will see an example. Let us consider 31, 21, 8, 10, 16. These are the elements of a heap. This is first, second, third, fourth and fifth. Now we will apply these steps, this procedure on this particular heap. So first of all, we will delete this 31. So first delete 31 because we have to delete from the root. So this 31 is deleted. 21, 8 and 10. 10, 16, 'This is first, second, third, fourth and fifth. So in this heap there are 5 elements. Now we have deleted this 31. Now the next step is we will replace this deleted node by the last element. So replace root by 16. So it comes out to be 16, 21, 8, 10, 'Like this. So we have replaced the last value, this is 16, with the root. So this is 16, 21, 8, 10. Now we will see, we will check whether this is heap or not. No, this is not the heap because 16 is less than 21. So what we will do, we will swap. Now swap 16 and 21. So swap these two values to restore the property of the heap. So now after swapping, it comes out to be 21, 16, 8 and 10. 21, 16, 8 and then 10. So this is first, second, third, fourth. First, second, third and fourth. Now this is the max heap now. This is the max heap because the value of the parent is greater than the children. So now we can delete the element. Now we will delete again root. Delete 21 now. Delete 21. So this 21 is deleted. 16, 8 and 10. Now after deleting 21, you will replace the deleted node with the last element. So last element is 10. So replace root by 10. So it comes out to be 10, 16, 8 like this. Now we'll check whether the parent is greater than its children. Now here this parent, this is less than, this 10 is less than 16. Therefore we will swap 10 and 16. So it comes out to be 16, 10 and 8. So in this way we have swapped this 10 and 16. Now this is the Maxheap now. It has restored its order property. So this is Maxheap now. Now we will delete 16. Delete 16. So it comes out to be like this. Is deleted. Now what we will do? We will replace the deleted element by the last element. Now the last element is 8. This is 8. Now it comes out to be 8 and 10. Now again we will check this 8 is less than 10. So we have to restore it. So what we will do? We will re-heapify, or we will heapify downward to restore its order property. So swap 8 and 10. Swap 8 and 10. Swap 8 and 10. It comes out to be 10. Like this, 8. So now it is Maxheap. This is the Maxheap. Now we delete 10. Delete 10. So it comes out to be like this. Now replace the deleted element with the last element. So replace root by 8. So this will be like this, 8. Now 8 is the only element, so we will delete 8. Finally delete 8. So this 8 is deleted. This 8 is deleted. It indicates that no more element left. So all the elements are deleted. So we can say this is another way of sorting. So this is another way of sorting an unsorted array. So earlier we were having the elements, like we were having the elements in the list 31, 21, 8, 10 and 16. And now we are having the element one by one we have deleted. So we can write in this way. First we deleted 31. So we can write 31. This is 31. And then 21 we have deleted. 21. And then 16. Then 10. And then finally 8. So this is the sorted list after deletion. So this is the sorted list. First we deleted 31, then 21, then 16, then 10 and then 8. So in this way we can delete the element. So in this video we have seen, first we have seen the insertion and then we saw how we can delete the element. Thank you.